Hello everyone, welcome to this video on Mendeleev's periodic table. But first, do you guys know which element is on number 101 on the modern periodic table? It's called Mendeleevium. It's named after the Russian chemist Dmitri Ivanovich Mendeleev, who is considered as the father of periodic table. He was the most important contributor for the early development of a periodic table, where elements were arranged on the basis of their atomic mass and their similarity of chemical and physical properties. Now, his periodic table was very different from the modern periodic table, and in this video, our focus will be how Mendeleev's periodic table differs from the modern periodic table. So it was in 1869 when only 63 elements were discovered, and Mendeleev went on to arrange these 63 elements in the increasing order of their atomic masses, and he found out that the elements with similar physical and chemical properties occur at regular intervals. So let's discuss these three things: atomic mass, physical, and chemical properties. So, what is atomic mass? It's very easy. It's the mass of one atom of an element. SI unit of mass is kilograms. Since the atom is very small, a more appropriate unit is used, that is AMU, atomic mass unit. Let's take an example here. Hydrogen, which has an atomic mass of approx 1 AMU, and carbon has atomic mass of 12 AMU. Now let's talk about physical properties and chemical properties of an element. Things like density, melting point, and boiling point of elements is its physical properties, whereas chemical properties is how an element reacts with other elements, especially with hydrogen and oxygen, because they are very highly reactive and form compounds with other elements. Mendeleev used the formula of oxides and hydrides to group the elements together. Now let's take a look at Mendeleev's periodic table. He observed that the elements with similar properties fall in the same vertical column. These vertical columns are called groups, and horizontal rows of elements are called periods. On this basis, he formulated his own periodic law, which states the properties of elements are periodic functions of their atomic masses. Now let's read some features of Mendeleev's periodic table. This table contains 8 vertical columns called groups and 7 horizontal rows called periods. He even predicted the existence of those elements which were yet to be discovered. Example given: Eka boron, Eka aluminium, Eka silicon, which after their discoveries were named as scandium, gallium, and germanium. And third point is, in order to group the elements having similar properties together at some places, he had to place an element with a slightly greater atomic mass before an element with a slightly lower atomic mass. Another achievement of Mendeleev's periodic table was regarding inert gases, or you can say noble gases. So the examples of inert or noble gases are helium, neon, krypton, and more. Inert gases were discovered very late because of their unreactive nature and low concentration in an atmosphere. But when they were discovered, they could be placed in a Mendeleev's periodic table in a separate group without disturbing other elements. So it was a great achievement. Now let's take a look at some drawbacks of Mendeleev's periodic table. First is position of hydrogen. The position of hydrogen was not fixed in the Mendeleev's periodic table, but it was kept with alkali metals. Second is position of isotopes. In Mendeleev's periodic table, no place was given to isotopes of elements. Third is uncertainty in atomic masses. Another problem was that the atomic mass does not increase in a regular manner on going from one element to the next. Placing of heavier elements before the lighter element. Few elements, those possess higher atomic mass, were placed before elements having a lower atomic mass. For example, argon with a mass of 39.9 approx was placed before potassium, whose mass is 39.1 approx. So till now, all the classifications including Mendeleev's were based on atomic mass. So elements were arranged in the increasing order of their atomic mass as periodic law stated. Properties of elements are a periodic functions of their atomic mass. Now, let's move to 1913, where Henry Moseley showed that atomic number is more fundamental property than atomic mass. So what's the difference between atomic mass and atomic number? So atomic mass, as we discussed it earlier, is the mass of a single atom of an element. And with the discovery of subatomic particles like electrons, neutrons, and protons, atomic number was defined as the number of protons present in the nucleus of an atom. So this was a complete shift, and everything was now based on atomic number. So elements were arranged in the increasing order of their atomic number in the modern periodic table. So you may be wondering, why didn't Mendeleev use the atomic number? Why was he using atomic mass? The reason is obviously Rutherford's nuclear model of an atom and the concept of atomic number was discovered after Mendeleev's death. So Mendeleev's table was based on atomic mass, but modern periodic table is based on atomic number. And that's all for today, guys. Thanks for watching. See you soon.